Chapter 1.3, Evaluating Limits Analytically, Day 3. Yesterday, we talked about evaluating limits by factoring and canceling. Today, we're going to evaluate limits by rationalization. An example where you may have to rationalize is whenever you see radicals. You see that you may have to rationalize by doing the plug and chug. If you plug in 3 to evaluate the limit, on the top you get 3 plus 1, the square of that is 2. 2 minus 2 is 0. So you got 0 on top, 3 minus 3 is 0. You got 0 on bottom. 0 over 0 means you have to do some more work. And that work is rationalizing. And so what we need to do here is we need to rationalize the radical to get rid of it on the top. And if you remember rationalizing when there's an addition or subtraction, we need to use what's called a conjugate. And I believe I just spelled that wrong. It should be a J there. A conjugate. Now a conjugate goes with a difference of squares. That'd be x minus a times x plus a equals x squared minus a squared. And if you look at what we got here, we got something minus something. So we have the x minus a part. So what we're going to need to do to rationalize and get rid of the square root up top, we're going to need to multiply by the conjugate of what we got in our numerator. And the conjugate is the exact same thing that we have in our numerator, except it's now adding. Just like right here, x plus a, we got the square root of x plus 1 plus 2 is our conjugate. Now we've changed the problem and we need to balance it off. When you multiply by something, to balance it, you divide by that same thing. Essentially, when you multiply the top and bottom by the same thing, you're really multiplying by 1. So when we multiply by 1, we haven't changed the problem. Multiply through on the top. We will FOIL that. Because it's a difference of squares, it's an easy FOILing. You just square the first term. The square root of x plus 1 squared is x plus 1 minus square the second term. This 2 squared is 4. The bottom, like when we did the factoring, we can just leave the bottom alone. X minus 3 times square root of x plus 1 plus 2. Let's clean that up. So we got the limit. As x approaches 3, on top we got x minus 3. And you can see why we left the top alone. On bottom we got why we left the bottom alone. On the bottom, we got x minus 3 times the square root of x plus 1 plus 2. Examining this, we got x minus 3 on the top and the bottom, so they cancel. Left with 1 up top. The limit, as x approaches 3, of 1 over the square root of x plus 1 plus 2. That leaves us with 1 over, substitute 3 in, 1 over 4. So when you plug in 0 over 0 and you get, when you plug in a number and you get 0 over 0, if there's a radical involved, you need to rationalize that radical out of that side of the fraction. Let's look at another example. Again, try the plug and chug. You'll see you get 0 over 0, so we need to use our conjugate to get rid of our radical. We will start, multiply top and bottom by the conjugate. The conjugate is exactly what you see there, except you change the sign. It'll be square root of 18 minus x plus 4. Do that to the top and bottom to keep balance. The limit, as x approaches 2, the bottom will stay the same. And then the top, we'll square that. We square the first terms. We get 18 minus x. We square the last term. We get 16. When we clean that up, the limit as x approaches 2, we got 18 minus 6 is 2 minus x over x minus 2, the square root of 18 minus x plus 4. Okay, we don't quite have anything that cancels here. However, if you look, this is 2, this is negative 2. They're opposites. This is x, this is negative x. They're opposites. We can make this work out if we just had the opposite of what's on the top. And we do that. To do that, we'll do the limit. As x approaches 2, we'll factor negative 1 from the top. If we factor negative 1, that changes the signs. And we'll have negative 2 plus x, which if we reorder, we get x minus 2. And now our top matches our bottom by factoring out that negative. The rest of the bottom stays the same. X minus 2's now cancel. And when we plug in 2, we got negative 1 up top. On the bottom, we got 18 minus 2 is 16. The square root of 16 is 4. Plus 4 is 8. Okay, this is not, obviously, a radical problem. We won't need to rationalize. Very similar to a problem we did yesterday, in that the fact that we'll need to simplify our fractions first. Okay? To do that, we multiply top and bottom by the lowest common denominator, which you just take both denominators. All right, leaving the bottom alone, we got the limit as x approaches 1, 2 times x minus 1 times x plus 1. Up top, we will distribute our 2 times x plus 1. Distribute our 2 times x plus 1. Here the x plus 1's will cancel. We'll be left with 2 minus, here as we distribute, the 2's cancel, we'll be left with x plus 1. Distribute our negative sign, we got the limit, as x approaches 1, 2 minus x minus 1 over 2 times x minus 1 times x plus 1. Simplify the top. We got the limit as x approaches 1. 2 minus 1 is 1 minus x over 2 times x minus 1 times x plus 1. Very similar to the last problem we just did. We have the same thing up top and bottom, except the signs are different. So we'll factor out a negative 1 up top. So that'll be negative 1 times x minus 1. Our bottom, again, we're going to just leave that alone. What happens here is the x minus 1's will cancel, and when we plug in what we got left, we plug in 1 up top, we got negative 1, and on the bottom, 1 plus 1 is 2, 2 times 2 is 4. So the answer is negative 1/4. And finally, this is, again, not a radical one, so we're not going to have to do a rationalization, but we are going to need to simplify it. Because if we plug in 0 for delta x, which means change in x. We get x squared minus x squared up top, which is 0 over 0. So what we do to simplify this one, we'll square this out. We'll square this out. And that means we're going to multiply it by itself. When we do that, we got x squared plus 2x delta x. You should know your squaring of binomial rules by now. Plus delta x squared minus x squared all over delta x. Taking a look here, x squared, negative x squared, they cancel. There's an x squared in both of these terms, so we can factor it out. So we got the limit as delta x approaches 0. Factoring out delta x, we're left with 2x plus delta x over delta x. Our delta x's cancel, and we are left with the limit as delta x approaches 0 of 2x plus delta x. Delta x goes to 0. This approaches 2x.